China's Chang'e-6 lunar probe has returned to Earth, bringing with it samples from the unexplored far side of the moon.
For decades, the moon has been more than just a glowing orb in the night sky. It's been a symbol of exploration, a canvas for myths, and a battleground for space supremacy. While the 20th century space race between the United States and the Soviet Union captured the world's attention, today, a new player has stepped into the spotlight. China's latest lunar mission has uncovered something so astonishing that it could challenge everything we thought we knew about our nearest cosmic neighbor. But what exactly did China find? How could this change the balance of power on Earth and our understanding of the moon itself? Stay with us as we explore the details behind this remarkable breakthrough and its far-reaching implications. To grasp the full impact of this discovery, we first need to look at how China's space program has rapidly evolved over the past 2 decades. From launching astronauts into orbit to assembling a cutting-edge space station, China's ambitions in space have expanded at an astonishing pace. But nothing has captured global attention quite like its lunar missions. The Chang'e program, named after the legendary moon goddess, has been at the heart of China's lunar exploration. In 2019, the Chang'e 4 mission became the first spacecraft to land on the moon's far side, an unprecedented achievement in space history. The success continued in 2020 with Chang'e 5, which collected and returned lunar samples, the first time in over 4 decades. Now, with the upcoming Chang'e 7 and Chang'e 8 missions, China is actively laying the groundwork for a permanent moon base by the 2030s. These efforts go beyond scientific curiosity. They signal China's determination to lead the next era of space exploration, and its latest discovery might just secure that position. The Chang'e 6 mission, a direct successor to Chang'e 5, was sent to explore the moon's south pole, a region of immense interest due to its potential water ice reserves. Equipped with advanced robotic technology and highly sophisticated instruments, the mission aimed to analyze the moon's surface with unprecedented precision. What scientists uncovered, however, was far more significant than anyone had expected. Hidden beneath the lunar surface, they found traces of a previously unknown mineral. This newly identified substance, named Changesite Y, exhibits properties that could reshape our understanding of the moon's formation and evolution. But that wasn't the only shocking revelation. Alongside this mineral, the probe detected unusual fluctuations in the moon's magnetic field, findings that challenge the long-held assumption that the moon is geologically inactive. These anomalies suggest a more complex and dynamic history than previously believed, raising questions about its past and its deep connection to Earth. The implications of these discoveries are profound. If validated, they could rewrite theories about the moon's origin, providing new insights into the formation of the solar system itself. Even more intriguing, these findings might help scientists understand the conditions necessary for life beyond Earth. Another breakthrough came in the search for water ice. Using highly advanced spectrometers, the Chang'e 6 probe identified areas with unusually high concentrations of hydrogen, a strong indicator of water ice deposits. This confirmation is crucial because water is not only essential for sustaining future human missions, but it can also be converted into fuel, making long-term lunar exploration much more viable. For years, scientists have speculated that frozen water exists in the moon's permanently shadowed regions, but China's discovery offers some of the most compelling evidence to date. This finding could revolutionize space exploration by making the moon a refueling station for future missions, significantly reducing costs and logistical hurdles. Why does this matter so much? If a sustainable water source can be harnessed on the moon, it changes everything. It would mean astronauts wouldn't have to transport vast amounts of water from Earth, dramatically cutting down mission expenses. Additionally, it sets the stage for deeper space exploration, potentially turning the Moon into a launch pad for Mars and beyond. The significance of this discovery hasn't gone unnoticed, especially in the United States. NASA, which is advancing its Artemis program to return humans to the Moon, now faces a new sense of urgency. The Artemis missions aim to establish a sustainable lunar presence within the next decade, but China's rapid progress has intensified the competition. The Moon is now more than a scientific target. It's a geopolitical battleground, with the potential to extract valuable resources like helium-3 and rare earth metals. Space is becoming an extension of global competition. China's latest advancements have raised concerns in Washington, fueling debates over whether the US is falling behind in this modern space race. There's also a growing fear of territorial disputes. While international agreements, such as the Outer Space Treaty of 1967, prohibit any nation from claiming lunar land, enforcement mechanisms remain weak. As China accelerates its space program, American officials are increasingly discussing how to secure their own foothold on the Moon. This situation mirrors the Cold War-era space race between the United States and the Soviet Union. Back then, space exploration was not just about scientific progress, it was a demonstration of technological dominance. Today, a similar competition is unfolding, this time between the US and China. China's latest discovery has only escalated tensions. The real contest isn't just about reaching the Moon, it's about who will control its resources and define the future of space exploration. The rivalry extends beyond the lunar surface, with space now considered a crucial domain for national security, economic growth, and technological supremacy. In response, the US and its allies are working to strengthen their collaborations in space. Initiatives like the Artemis Accords, which promote peaceful and cooperative exploration, have gained renewed importance as nations strategize to balance China's growing influence. Within the scientific community, China's breakthrough has sparked excitement and debate. Researchers worldwide are eager to examine the data, particularly the properties of Chandrasekhar-Y, which could open up new fields of study in planetary geology. However, concerns remain about transparency. China has historically kept much of its space research under strict control, leading to calls for greater international cooperation. Scientists argue that openly sharing findings benefits all of humanity and accelerates our understanding of space. At the same time, some researchers caution against overhyping the discovery. While the findings are undeniably groundbreaking, they stress the need for further analysis to confirm their significance. Science demands rigorous peer review, and it may take years before we fully understand what this discovery truly means. Furthermore, China's recent lunar discoveries are also opening doors to a potential trillion-dollar industry that could redefine global power structures. The Moon holds resources that could be game-changers. Among them are rare earth metals, vital for modern electronics, and helium-3, a substance long hailed as a possible fuel for nuclear fusion. If fusion technology becomes viable, helium-3 could provide an almost unlimited clean energy source, far beyond anything fossil fuels or even current renewable energy options can offer. Just 1 ton of helium-3 has the potential to power an entire country for a year. This isn't just theoretical science, it's a glimpse into a future energy revolution. With China at the forefront of lunar exploration, there's real concern that they could secure early access to these invaluable resources. If successful, this could grant them not just an economic edge, but a significant strategic advantage on the world stage. Control over lunar materials could reshape energy markets, shift economic alliances, and tilt global influence in China's favor. Other global players aren't standing by idly. the United States, through NASA's Artemis program, and agencies in Europe and Japan are racing to stake their claims in this new space frontier. Private companies, including SpaceX and Blue Origin, are also eyeing lunar opportunities. But this race is about more than flags and footprints. It's about securing long-term access to resources that could shape the next century of human progress. The economic implications are massive. Analysts estimate the lunar economy could be worth trillions in the coming decades. Beyond mining, there's potential for developing infrastructure like lunar habitats, energy grids, and transportation networks. Imagine manufacturing satellites directly on the Moon, bypassing the costly process of launching heavy equipment from Earth. This could revolutionize industries and lower the costs of space operations across the board. Yet, the Moon's value isn't just in what lies beneath its surface. Its strategic position makes it an ideal launch point for deeper space missions. Establishing a base there could dramatically cut travel time and fuel costs for journeys to Mars and beyond. In that sense, the Moon is a gateway to the solar system. But this rapid push into lunar territory raises critical ethical and legal questions. Who truly owns the Moon? Can any nation or private company claim its resources? International space law is murky at best. The Outer Space Treaty of 1967, ratified by over 100 countries, declares space the province of all mankind and prohibits national sovereignty over celestial bodies. Yet, it leaves significant gaps regarding resource extraction and private enterprise. Without clear regulations, there's growing concern that the Moon could become a lawless frontier, a modern-day Wild West where whoever gets there first takes what they can. Environmental considerations also loom large. The Moon may seem desolate, but its landscape is a record of the solar system's history. Mining operations risk disturbing this fragile environment, potentially creating harmful lunar dust clouds or permanently altering its surface. As we reach for the stars, how do we balance ambition with responsibility? Will humanity collaborate to unlock the Moon's potential, or will competition lead to conflict? Let us know your thoughts in the comments. Don't forget to subscribe for more, and thanks for watching.